Any social research project has to deal with concerns about measurement bias. Measurement bias occurs when we construct our data collection methods in a way that influences our respondents' answers. When that happens, the results that we get may be less a reflection of how our subjects actually are and more a reflection of our own biases that we brought to the table and may have incorporated into the study. Now, there's no silver bullet for solving measurement problems. It requires some judgment. Still, it's good to know what it is and how to deal with it. And that's the topic of this video. In your research project, people will give different answers to your questions. That's a good thing. People are genuinely different, and part of the reason that we're asking these questions are to find out how they're different. At the same time, the answers you receive are not just a product of people's genuine differences. Perhaps a good place to start when discussing measurement problems is to differentiate two sources of variation, two reasons that people give the scores they give and why people give different scores. Those two sources of variation are true variation and measurement error. True variation means that a measure is capturing people as they really are, and they're giving different scores because they're actually different. Measurement error occurs because there's a problem in the question. It's not completely capturing the characteristics or the information that you're trying to get from your subjects. Not all measurement error is the same either. There's two types, random and systematic. Random error is unpredictable errors that don't necessarily push a study's results in one direction or another. So when you're conducting a study, there's all types of reasons or all sorts of unanticipated reasons that a respondent might not give an accurate answer of himself or herself. For example, maybe a respondent misread the question, or if there was a multiple choice question, maybe they had meant to fill out B, but they accidentally filled out C. Maybe your question asked them to perform mental calculations and they made a mistake. For example, you asked them how old they are, and they forgot that they were 37. They've been saying they're 34 for the last 3 years, and they write in 34. That's error, because your measurement isn't reflecting your respondent's true characteristics, but it's random error. You don't know where it's going to pop up. You don't know exactly who's going to commit the error, and it's not like all of your respondents are going to commit the same type of error in a way that would bias your overall findings. Systematic error is a little bit different. Systematic error happens when there's something in the question or the measurement scheme itself that pushes all respondents to answer erroneously and in the same way. Let me give you an example. Here's an example of a question that would probably produce. Here's another example of a question that might produce systematic error. Let's say I wanted to find out who a high school graduate and athletic, so they have to be both. And I asked the question like this: are you a high school graduate, an athlete, yes or no? Now, there's bound to be some confusion because I didn't say and an athlete or an athlete. I assumed I meant, are you a high school graduate and an athlete? But some people might have read it as, are you a high school graduate or an athlete? And might answer yes if they graduated high school, but they're not an athlete, or yes if they were athletes but didn't graduate high school. In this situation, my results are probably not going to properly capture who's both a high school graduate and an athlete. My question was unclear. It affected people's answers, and so my estimates are off. A really common way to describe a measurement error or to depict it is to give this bullseye graph. So imagine the center of the bullseye is the true answer for everybody, and the shots are examples of what their scores registered when I measured them. Okay. Now, if there's a lot of random error in my study, answers will be all over the place. Maybe somebody will accidentally answer C instead of D, but I can assume that for every person who accidentally answers one question too low, someone else will answer it too high. Somebody will put an E instead of a D. In situations with a lot of random error, the worst case scenario is that I get just a lot of noise. I can't really tell from my measurements what the population is really like. Systematic error is much more dangerous because there's a possibility that I'll get what appear to be very highly or very precise answers, but the answers are wrong. Why is that a problem? Well, think about how research is used in decision making. A lot of random error, you give it to a decision maker, and the decision maker is probably going to say, "We don't know. I can't tell from your data what my best choice is. Your answers are all over the place." In contrast, a lot of systematic error could give the impression of a highly definitive finding. So it looks like your studies are conclusive, and your client looks at your results, goes, "Well, it's quite clear what I have to do based on your results." And he or she goes and makes a decision based on your faulty results. A confident wrong finding is much, much worse than a uncertain finding that doesn't tell us much.
Measurement error is an inescapable problem. It plagues all studies. It's an issue that you can't get rid of. At best, you can be cognizant of its existence and try to keep your eye open for problems in your research measurement design that will cause these types of errors to become egregious. You have to use your judgment. But there are some basic tips that you might want to follow. Number one, make your questions and potential answers as clear as possible. Don't make it hard to understand the question, give a direct answer, or code it. Those types of pitfalls can create error. Second, when you design a survey, pre-test it. That means bring it to some people, give them the test, and then go over the answers with them and make sure that the answers that you received are what they really meant. Talk to them about whether or not the wording of your question made them feel like they should answer a particular way, or whether or not the design of your survey caused them to stop paying attention, if the little ovals were too hard to fill out, or there was some other problem that could lend itself to error. Just don't ignore the problem. Bad data creates a bad analysis, and if you have a lot of error in your survey, your analysis could be all for naught.